Hello, boys and girls. Welcome to 3-2 Subtract Integers Part B. In this section, we're going to be going through the reveal pages and completing the notes in our workbooks. This section starts on page 139, right? And your I can statement is I can use different methods, including algebra tiles. Those are our two-color counters. Number lines, which we'll look at in the reveal pages, or the additive inverse, which is the keep, change, switch that we've been using to subtract integers. So you're already doing the algebra tiles and the additive inverse. We just need to learn the number lines, which is covered here in these reveal pages. Here we have number line example. They're modeling the problem 4 minus 9, which is problematic because 9 is bigger than 4, so we're going to end up with a negative answer. To show how you can use a number line, they say start at 0. To model a positive 4, you would go right 4. And then to show that you're subtracting 9, you would go left 9. However, they want you to find the additive inverse in order to do this. All right, so I'm going to try this again. Last time I did this, my pen malfunctioned, and I had to start the whole video over again. Let's see how it works today. Now it's being very touchy. All right, well, we'll write up here then. If we had 4 minus 9, why is this acting so badly? Let me switch pens. Maybe if I switch pens. That pen's not working right. I don't know if it's the board that's not working right or if it's the pen, but we'll see. Okay, so we do 4 minus 9. This pen works better. To do the additive inverse, you keep the first number the same. You change subtract to add. And you switch the sign of the second number. So now we're going to make 9 negative, okay? Now, because we have two numbers with different signs, we subtract the 4 from the 9, which gives us 5, and the answer always takes the sign of the bigger number. So we knew we were going to end up at negative 5, but on the number line method, you start at 0, you go up 4 to represent positive 4, and then a negative 9 would be down 9. I wonder why my pen's not working. Okay, so here they have another example, 5 minus negative 7. 5 minus negative 7, okay? Well, we want to keep the first number the same, change subtract to add, and switch the sign of the second number, which gives us 5 plus 7, which none of you actually need a number line to add that. If we start at 0, if 5 is positive, so we would go right 5. 7 is also positive, so we would travel 7 more to the right, and we would land on 12, which I think we all knew that 5 plus 7 is 12. But there's your number line method. All right, they want you to find this one on the number line that they didn't give you. So we keep the first number the same, we change subtract to add, and we switch the sign of the second number. Well, again, nobody really needs a number line to do this one. Let's say we have 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be 11, and then we would have to go 15 more, which is going to get really small. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which lands us at 26. There we go. That was fun. Okay. So here they want you to use the additive inverse, okay, which is how I was teaching you to do it in the first video. We keep the first number the same. They kept negative 24. We change subtract to add, and we switch the sign of the second number. All right, they call this adding the additive inverse. 17 is the additive inverse of negative 17. That means they add up to 0, whatever. So then, once you've got this, the signs are different, so you subtract 17 from 24, which gives you 7, and the answer takes the sign of the bigger number. Okay? Here's our check. We keep the first number the same, we change subtract to add, and we switch the sign of the second number. Well, because these have different signs, we're going to subtract the smaller one, 24, from the bigger one, 39, which gives us 15. Is it a positive 15 or a negative 15? Well, the bigger number was negative, so 15 is also negative. Moving on, example 3 on page 141. This is where we learn to substitute values, okay? They've given us x minus y, and they said let x be negative 23 and y be 19. So what they do is they take the x out and they put the negative 23 in, take the y out, put the 19 in, and remember this was a minus sign here, so there's a minus sign there. Then we keep the first number the same, we change subtract to add, and we switch the sign of the second number. But now we realize these two are both negative. So because they're both negative, we can just add them together. 23 plus 19 is 42, but because they were both negative, 42 is also negative. I've given you a chance to do this yourself. They're saying evaluate P minus Q if P is negative 21. P is negative 21, and Q is 37. Well, now we keep the first number the same, we change, subtract, add, and we switch the sign of the second number. So now 37 is negative. Now they're both negative, so we just add them together, which gives us 58, and it's a negative 58 because we added two negatives together. Now they want you to find the distance between integers, okay? In this point, they start talking about absolute value signs. See here, these are absolute value signs. They want to know how far is one number from the other number on the number line. So we stop caring if they are positive or negative. We just want to know what's the difference between them. So for example, what's the distance between negative 4 and 5? They put a dot here at negative 4 and a dot at 5, and you just count the number of spaces between them. Okay, so the space between negative 4 and 5 is 9. Okay. Over here, you could use an expression. They want you to use these absolute value symbols because they want you to understand that distance is always positive, and absolute value symbols make anything inside of them positive. Negative 4 plus negative 5 is negative 9. Okay, but the absolute value of negative 9 is 9 because there are 9 units. Distance is always positive. All right, not important. This, I will not test you on that. Okay, what is the distance between negative 9 and 8? Well, negative 9 would be right here before 10, and 8 would be right here. So the distance between negative 9 and 8 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 units between those two numbers. But you start to realize it would have been easier to just add 9 and 8 together because it gives you 17. So what I'm saying is when we're finding distance, disregard the negative and just add the two numbers together. Okay? So here, this same thing. It gives you 17, 17, 17. All right, find the distance between negative 5 and 9 on the number line that they did not give us. I don't know why I can't draw a straight line on this thing. 1, 2, 3, 4, 5. So this would be negative 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 9. So obviously, this is going to be 5 spaces, and this is going to be 9 spaces. So what's the distance between them? 14 spaces. All right, so the distance is 14 units. So taking that idea to a word problem now, they're saying the highest point in California is Mount Whitney with an elevation of 14,494 feet. That's up here. The lowest point is Death Valley with an elevation of negative 282. Okay, what is the distance between the highest point and the lowest point? So what you're going to do is you're going to be adding these two distances together. We don't care that this is a negative 282. What we care is that that is 282 feet and that is 14,000 some feet, and we want to add them together. All right, so that's what they're using these absolute value symbols for, to show that we're adding them together. Now, how did they set this up? They took the highest point and they said, what is the difference between that one and the lowest point? So difference is always subtract. So they did 14,494 minus negative 282. But you remember, minus a negative turns into adding a positive, or you can keep, change, switch, and you get positive. You add those together, and then the absolute value is 14,776. So we have let's draw a little picture here. We have a top of an iceberg, and then lots of iceberg underneath the ground. Okay. The top of an iceberg is 55 feet above sea level, and the bottom is 385 feet below sea level. So this is 385, and this is 55. What is the distance between the top and the bottom of the iceberg? What is the whole distance? Well, you would add these two together. 385 plus 55, 0, carrier 1, 14, carrier 1, 440. 440 feet between the top and the bottom. Pretty cool. See what I did there? Icebergs are like made of ice, and they're cold, so I said pretty cool. No, never mind. The table shows the minimum and maximum temperatures on various celestial objects in the solar system. Scientists want to send a probe to study the celestial object with the greatest variation in temperature. To which celestial object should they send the probe? Okay, so they want to send this probe to whatever one of these guys has the biggest difference in temperature from minimum to maximum. Immediately, we know Venus is not going to be a winner here because there is no variation whatsoever here. This is exactly the same. It's the same all the time on Venus, and it's pretty darn hot. I don't think I want to go to Venus. But looking at the other three possibilities, my money is on my money's on Mercury. Look how high that high temperature is. That's really high. Okay, this one is the one I think is going to be winner, winner, chicken dinner. But let's see. If we add, and I'll just use a calculator for this. In class, I did it the long, old-fashioned way, but we don't need a long, old-fashioned video here. 387 plus 253 gives us 640, a difference of 640 degrees on the moon. For Mars, 225 plus 70, oh, I could have done that in my head, is 295. 295 degrees of variation on Mars. But Mercury, the one I think is the winner, 279 plus 801, which gives us 1,080 degrees of difference on Mercury. So guess what? Mercury wins. It has the greatest variation. Which one had the least variation? Venus. The table shows the highest and lowest points of elevation in relation to sea level in 4 countries. So this is kind of like our Mount Whitney, Death Valley example. This is the highest point in Jordan. This is the lowest point in Jordan. Highest point in the UK, lowest point in the UK. They want to know which country has the greatest variation and which has the least. So in every case, we're adding these two numbers together, not caring that these are negative, okay? We just want the distances to be added together. Well, Jordan looks like it's going to win the greatest. 6,083 plus 1,404 is a whopping 7,487. The UK, I can do that one in my head. That's going to be 4,419, not winning. Sweden, okay, that would be 6,911. And Ireland would be 3,416. I'm just adding these numbers together, pretending these are not negative, okay? What I would do is I would do this number minus this number, and then we would keep change. This is why I can add these two, okay? I want to know the difference between this and this, so difference means subtract, be this one minus that, and we would go keep change. That's why it's okay to add those. So which one has the greatest? Greatest is Jordan, has the biggest number, and the least variation would go to Ireland. Right. Well, that brings us to the practice assignment, which will be another video. I'm going to do the practice problems actually on McGraw-Hill in the next video. So you can be looking for that one to come out here in the next 24 hours. In the meantime, thank you for joining me. I hope you enjoyed it as much as I did, and have a great rest of your day.